Okay, so for number 1, we have to look at the angle pairs. So first one is F and H. So if we scroll on down to our figure, we have F and H right here. F is made up of this angle. H is made up of this angle. And you can see it makes an X. Since they're on opposite sides of the X shape, these are called vertical angles, and you should know that vertical angles are congruent. So first angle pair, vertical angles, and their angle measure relationship is that they are congruent, which is another word for equal. Okay. So G and D, if we take a look at G and D, they look similar to vertical angles, but they aren't vertical angles. The reason being is that D is made up of this line and this line, which stops right here. So because that line stops and doesn't continue to go, G and D are not vertical angles. So these guys actually have no relationship. So therefore they are neither congruent nor supplementary. H and A, so you can see H and A are right here, and we have the parallel lines. So have those parallel lines continue out. They go on forever and ever, and they never cross. Cut by a transversal, if we were to extend that out. Okay. And if you look closely, you can see this shape, which is in your notes. And so H and A are between the parallel lines, so they are interior. H is on the left side of the transversal, H is on the right side of the transversal, so they are on opposite sides. So therefore, they are alternate interior angles. And from our notes, we know that those alternate interior angles are congruent. E and C. So E and C are right here. And again, we have these parallel lines that are supposed to go on forever. So let's pretend they go on forever with another transversal right here. So E and C are both between the parallel lines, so therefore they are interior. E is on the left side of the transversal, C is on the right side of the transversal. Therefore, we have another set of alternate interior angles. And those guys are congruent. Okay. F and G are right along the top. Okay. If you were to remove this piece coming out, they would form a straight line, which means they add to 180 degrees. So we would call this a linear pair. And the word for that is supplementary. Some students wrote supplementary in both, and that's totally fine. Next, we have angle F and angle A. So again, angle F and angle A are along these parallel lines. If we take a look at this intersection right here, where all of these graphs cross, all the lines cross, we would see that F is in the top left. It's formed by the parallel line and the transversal. And A is also formed by the parallel line and the transversal. So since they are in the same position, okay, one looks like that, the other one looks like that. Okay. Since they are in the same position, those are called corresponding angles. Corresponding. And those are congruent. Okay, next up, for number 2, A, B, and C, it says to identify the relationship and use what we know to write an equation and solve. So first step, I'm going to identify what relationship they have. In this intersection, 102 is in the top left. Within this intersection, x plus 15 is also in the top left. So since they are in the same position of their corresponding intersections, these are corresponding angles. And because they are corresponding, you set them equal to each other. So subtract 15 from both sides, and x is equal to 87 degrees. For part B, whenever you have this x, there's two situations. You either have situations like part B, which are vertical angles, or situations like part C, which are a linear pair, or supplementary. If you tried to draw a line from this equation to this equation, you would have to cross an empty angle. If you tried to draw a line from this equation to this equation, you don't have an empty angle. That's the difference between vertical and supplementary. So for vertical lines, we set them equal to each other. X plus 21 is equal to 7x minus 3. Subtract x from both sides, and we get 21 equals 6x minus 3. Add 3 to both sides, so 24 is equal to 6x. And divide both sides by 6 to get 4 is equal to x. If you plug 4 back into that equation, you would see that they are equal to each other. That's how you would check your work. For supplementary angles, those are angles that add to 180 degrees. So 3x plus 8 plus 2x plus 2 is equal to 180 degrees. Combine like terms to get 5x plus 10 is equal to 180 degrees. Subtract 10 from both sides, and you get 5x is equal to 170. And divide both sides by 5 to get x is equal to 34 degrees. Okay. Write each expression as a product, or write the product as a sum, and they want us to draw an area model. So to draw an area model, we're going to draw the square. I know some students can solve this using the FOIL method, but because the instructions asked us for an area model, we do have to use an area model. So we have x plus 4, x minus 5. So x times x is x squared. X times negative 5 is negative 5x. 4 times x is 4x. And 4 times negative 5 is negative 20. So to write as a sum, we're going to add the insides together. Our area is equal to x squared plus 4x minus 5x minus 20. And we can combine like terms to be x squared minus x minus 20. Final answer. For part B, same situation. We're going to make an area model. 3x minus 2, x minus 1. 3x times x is 3x squared. 3x times negative 1 is negative 3x. Negative 2 times x is negative 2x. Negative 2 times negative 1 is a positive 2. So our area is equal to 3x squared minus 2x minus 3x plus 2, or 3x squared minus 5x plus 2. For part C, this is different than the other two parts because in A and B they're both binomials. For part C, x is a monomial. So we can have our area model just be a rectangle with two spaces, x on the outside and 3x minus 2 on the top. 3x times x is 3x squared. Negative 2 times x is negative 2x. So our area here is 3x squared minus 2x. Okay. On the back side, on the top, that was just the second part of the problem asking us for the area. It just bled onto the second side, so don't worry about that. We already fixed that. For number 4, we have to use the area model, and we need to find the outsides, the insides, and write the area as a product and as a sum. So to find the inside of the rectangle, we need to find area. So 3x times x is 3x squared. But now we've got to work on the outsides. So if to get into the box, I need to multiply. To get out of the box, I'll need to divide. So 18x divided by 3x gives us a positive 6. Negative 2x divided by x leaves just a negative 2. And now we have our outsides. For this last box, I have negative 2 times 6, which is negative 12. So our product is going to be the outsides multiplied together. I have a positive x and a positive 6, so that's x plus 6. And 3x minus 2, 3x minus 2. For the sum, we add them all together, 3x squared plus 16x minus 12. By the way, when you do the sum, you can just add from here. The x squared and the number usually point together on the diagonal. And the other two, which both have just singular x's, are what can be combined. Okay, for part B, same situation. I have a negative 42y divided by negative 7 gives me a positive 6y. And 18y squared divided by 6y would leave me with a 3y. 3y times negative 4 is negative 12. And negative 7 times negative 4 is a positive 28. So as a product, it's 3y minus 7 times 6y minus 4. And for the area, I have my 18y squared as a sum, negative 42y. I forgot this is supposed to be negative 12y. Negative 4 times 3y is negative 12y, my mistake. Negative 42 minus 12 is a negative 54y plus 28. Okay. For the graph, I apologize, it's kind of hard to read. But we should have negative 6, 4. So negative 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. We'll label that A. B is located at negative 2, 10. So here was B. There shouldn't be a prime on there. And C should be right 8, 1, 2, 3, 4, 5, 6, 7, 8, up 1, 2, 3. And there's C. Connect them all to make our shape. And it says to reflect over the x-axis, which means we have to count how far away each of those points are from the x-axis. So A is 1, 2, 3, 4 above. So 1, 2, 3, 4 below is our new A. A prime. B is 10 above the x-axis, so we'll go 10 below. C is 3 above the x-axis, so 1, 2, 3 below. Yeah. And our new vertices are going to be negative 6, negative 4, negative 2, negative 10, and negative 8, positive 8, negative 3. So graph the quadrilateral. We have OPQR. O is at 1, 1. P is at 5, 1. 1, 2, 3, 4, 5, 1. So there's O. There's P. Q is at 2, 1, 2, 3, 4, 5, 6, 7. R is at 6, 7. 1, 2, 3, 4, 5, 6, 7. Right there. And this says rotate 90 degrees clockwise. In class, I asked them to change this to 180 degrees. And there's two ways you could do this. You could either memorize the rule. And when you memorize the rule for 180 degree rotation is x, y becomes negative x, negative y. Alternatively, you can just turn your paper all the way around and just graph the same points. I turned it around 180 degrees, and my points were 1, 1, 5, 1, 2, 3, 2, 7, 2, 1, 2, 3, 4, 6, 7, and 6, 7. So you can do it that way. So this would be O prime, P prime, R prime, and Q prime. If we follow the rule, it's just make everything negative or change the sign. So O prime is negative 1, negative 1. P prime is negative 5, negative 1. Q prime, negative 2, negative 7. And R is negative 6, negative 7. Okay, the rule says take X and Y, keep them in the same spot, but change both their signs. Okay. For the polygon, isosceles triangles, are sides congruent? Yes. How many? 2. That's the definition of isosceles. Are sides parallel? No. Triangles can't have parallel sides. Are angles congruent? Yes. There's 2. Are there any right angles? Possibly. It depends. You could have an isosceles triangle. I'll do a little scratch work at the bottom. You could have an isosceles triangle that looks like that. You could also have an isosceles triangle that looks like this. So it really depends. Does it have rotational symmetry? No. Which means you can't rotate it and get the same shape back. However, it does have reflectional symmetry, because if you were to divide it down the middle of the point between the congruent sides, it could flip on top of itself. So yes, it does have reflectional symmetry. For a right triangle, are sides congruent? If so, how many? Possibly 2. Here is an example of a right triangle without 2 congruent sides. And here's my other right triangle with 2 congruent sides. So, depends. Are sides parallel? No, triangles can't be parallel. Are angles congruent? Possibly 2. Okay. In this case, no. But for this guy right here, if it's an isosceles right triangle, then that means these base angles would both be 45 degrees. Are there any right triangles? Yes, that's the definition of right triangle. 1. Does the polygon have rotational symmetry? No. But does it have reflectional symmetry? Possibly. And again, 2 examples where it could have reflectional symmetry and not reflectional symmetry. Okay. Equilateral triangle. It's literally in the name. Equa means equal. So are sides congruent? Yes. All 3 sides. Are sides parallel? No, it's a triangle. Are angles congruent? Yes, all three. Are there any right angles? No, not at all. If you had three congruent angles and they were all 90, 90 plus 90 plus 90 does not equal 180 degrees. So it's impossible to have a right angle in an equilateral triangle. Does the polygon have rotational symmetry? Nope. Actually, yes it does. I lied. Yes. And does it have reflectional symmetry? Yes. Okay. Equilateral does have rotational symmetry. It can rotate in 60-degree increments. For parallelogram, are sides congruent? Yes. Two pairs of congruent sides. The opposite sides are congruent. Are sides parallel? Yes. Two pairs. That's the definition of a parallelogram, made up of parallel lines. Are angles congruent? Yes. Two pairs. The opposite side. Are there any right triangles or any right angles? Possibly. Possibly four. Does it have rotational symmetry? Yes, it has 180-degree symmetry. And does the polygon have reflectional symmetry? Possibly. Okay. If the parallelogram is a rhombus or a rectangle, yes. Okay, but we don't know the parallelogram is not a rectangle or rhombus. Okay, for a rhombus, are sides congruent? Yes. All four sides. Are sides parallel? Yes. A rhombus is a special parallelogram. There's two pairs. Are angles congruent? Yes, two pairs. Are there any right angles? Possibly. Here's a rhombus without right angles, and here's a rhombus with right angles. Does it have rotational symmetry? Yes, 180 degrees. Which means if I took my paper and I turned it upside down, boom, got the same shape. Okay. And does the polygon have reflectional symmetry? Yes, along its diagonal. Okay, on the back, and I'm going to use another pair to help me out. Okay, are sides congruent in a rectangle? That answer is yes. Two pairs. Are the sides parallel? Yes. Two pairs. Are the sides congruent? Are the angles congruent? Yes. Four. They are all 90-degree angles because that's the definition of a rectangle. Are there any right angles? Yes. Four. Does the polygon have rotational symmetry? Yes. Reflectional symmetry? Yes. Trapezoid. Are sides congruent? If so, how many? Possibly two. If it's an isosceles trapezoid, yes. If it's a regular trapezoid, only if it's isosceles. Are sides parallel? Yes, there is only one pair of parallel sides. That's the definition for a trapezoid. Are angles congruent? If so, how many? And a trapezoid, possibly. Okay. An isosceles trapezoid, yes, 2 pairs. So in a trapezoid, here is one trapezoid with one pair of congruent angles, a right trapezoid, if you will. And here's a trapezoid without a pair of congruent angles. So it really just depends. Okay. Are there any right angles? Possibly. I just showed you guys a picture where they could have right angles. In this one, no. Isosceles trapezoid cannot have right angles, because otherwise it would be a square, and then they would have 2 pairs of parallel sides. Does the polygon have rotational symmetry? No. Reflectional symmetry? No and yes. Well, I guess this would be possibly. Depends on if it's in an isosceles triangle. Sorry, isosceles trapezoid. Okay, regular hexagon. The word regular means that all sides and all angles are congruent. So are all sides congruent? Yes. 6 congruent sides. Are sides parallel? Yes, there are 3 pairs. 2 on each side. Are all angles congruent? Yes, that's the definition of regular. 6 angles. Are there any right angles? No. The more sides you add to the shape, the bigger the angles become. Does the polygon have rotational symmetry? Yes. Does it have reflectional symmetry? Yes. Regular octagon, are they congruent? Yes, there are 8 sides. That's the definition of regular. Are they parallel? Yes, there are 4 pairs. Are angles congruent? Yep, 8 angles. Are there any right angles? No, it's too big. And yes, they have rotational and reflective symmetry. For number 7, this is basically what we did for warm-up last Friday with all the different colored string. So I got 3 plus 5. Is it greater than 6? Check. Yes, 8 is greater than 6. When you add the 2 smaller sides, is it bigger than the third side? Yes, that's a triangle. It's not adding the first 2 numbers, it's adding the 2 smallest sides. So is 4 plus 7 bigger than 10? Indeed it is. 8 plus 17 is bigger than 23, which is 25 bigger than 23. Yep, that's a triangle. 10 plus 10 is bigger than 15. Yep, it's bigger. It's a triangle. And 20 plus 20, is that bigger than 50? 40 bigger than 50? No, that is wrong. 40 is smaller than 50, so this could not be a triangle. The first 5 worked. This one will not be a triangle. The reason being, okay, if we go back to our string, okay, if I were to take a purple piece of yarn, that's a little bit longer because it's kind of falling apart, a blue piece of yarn, and a red piece of yarn. Okay. Those 2 little pieces do not make enough to connect, so therefore we will never be able to make a triangle out of it. Okay. That's why you have to have 2 sides that are bigger than the third side, so that way they can connect like that. All right. Javier started the year with $425 in the bank and is saving $25 per week. So let X equal the number of weeks, and let Y equal money saved in the bank. So for Javier, he starts off with 425 and he makes 25 per week. So this would be y equals 25 per week, and he started with $425. Shane, y equals, he makes $15 a week, and he has $640 all saved up. So be on the lookout for the phrase a week, per week. That is always a signal it's going to be attached to a variable. So for who will reach 1,000 first, let's plug it in and solve. So 1,000 equals 25x plus 425. That's Javi. And Shane would be 1,000 equals 15x plus 640. So let's solve. Subtract 425 from both sides. I got 575 is equal to 25x. Divide both sides by 25. And we get 3, x is 23. So it'll take Javi 23 weeks. And if we subtract 640 from both sides, we get 360 equals 15x. Divide both sides by 15, and we get 224 equals x. So because this is the lower number, Javier will reach $1,000 first. It will take Shane one more week to reach $1,000. All right. Okay, study hard. Good luck. I'll see you guys tomorrow.